Next, we're going to talk about scientific notation. Scientific notation is a means of expressing either very, very large numbers or very, very small numbers. You express the number as a digit or a number between 1 and 10 multiplied by 10 raised to a power. Here are some examples. This very long number, 2923, and then a whole bunch of zeros, is expressed as 2.923 times 10 to the 14th. This very small number, preceded by a bunch of zeros, is 2.31 times 10 to the minus 7. So how do we do this? Well, let's take a look back at the ones we just looked at. Again, you express it as a digit between 1 and 10. So you take the number and put your decimal right here, and then you count. You count from here, and however many spaces you count going to the left is the number that you raise the power of 10 to. And if you move the decimal to the left, then it's a positive. You count this way, 1, 2, 3, 4, 5, 6, 7. And since you move to the right, it's a minus number. So let's do an example. How about this one? 541200. Write on a piece of paper how you would express that in scientific notation. It would be 5.412 times 10 to the 5th. And the way you would get that is you'd go 1, 2, 3, 4, 5, 10 to the 5th. So this would be 5.412 times 10 to the 5th. This one, you would put your decimal right here, 6.101, and it would be times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. So it's 6.101 times 10 to the 8th. This one would be 4.51 times 10 to the 1, 2, 3, 4. 10 to the minus 4. 4.51 times 10 to the minus 4. Now you can express each of these as a real number. Now this is much less commonly done, but 365 times 10 to the 5th, you would write this number down, and then you would move the decimal 5 places to the right. So it would go 1, 2, 3, 4, 5. So it would be 365,000 with 3 zeros. This one you'd move this way, so you go 1 and then a bunch of zeros. So it'd be 0.00000061122. This would be similarly 0.00099912. There will be one less zero than there is number here. So that in this one there will be 6 zeros and then this number. So it would be 0.0000006. And this one would have 3 zeros. 0.0009, because this is a 4. Now when you multiply, you add the exponents to the tens. So this one would be 5.41 times 6.12. 5.41 times 6.12. Now that's 33.1092, but these each have 3 significant figures, so you would round that down to 33.1 times 10. 3 plus 2 is to the 5th. So it's 33.1 times 10 to the 5th, but remember it has to be a digit between 1 and 10. So the correct answer would be 3.31 times 10 to the 6th. because you have to move the decimal over 1 to make a digit between 1 and 10. Now when you divide, you subtract the exponents. So 2.934 divided by 4.491. Now that's going to equal 0.65330, etc. There's 4 significant digits in each of these, so it's 0.6533 times 10 to the minus 2, because you subtract 6 from 4. But remember again, it has to be a digit between 1 and 10, so you move the decimal over 1 place to the right to make it 6.533, and you change to the minus 2, you change that to the minus 1. Now when you subtract or add, you have to change them so that it's like finding the least common denominator in a fraction. You have to change one of the two numbers so that both of them are expressed to the same power. So you either have to change 1.144 times 10 to the third to some number times 10 to the 2, or you have to change 2.344 times 10 to the 2 to some number times 10 to the 3. And I'm just going to change the first one here. 1.144 times 10 to the third is the same as 11.44 times 10 to the 2. Then you subtract 2.344 from that, and you get 9.096, and that would be times 10 to the 2. And then the last one here is an add. You do the same thing. You have to change one so that they're common. And again, I'm going to change this first one from 3.765 times 10 to the minus 3. I'm going to change that to 0.3765 times 10 to the minus 2. So 0.3765 plus 3.515, that equals, and these are both to the same digits, so it would be 3.891 or 892 rounded up times 10 to the minus 2. 3.892 times 10 to the minus 2 would be the answer. Now let's look at units. Units are extremely important in mathematics because you have to make sure that you keep your measurements. In order to add two measurements, they have to be in the same units. You can't add a force unit to a length unit. You can't add a mass unit to a unit of sound or something like that. So the various systems have been developed to look at units. For example, the first system, the one that you might be familiar with, is in the United States, called the foot-pound-second system, FPS. That force is expressed in pounds. We talk about something weighing a certain amount. We talk about weighing something in pounds. The length is expressed in feet. And the mass is expressed in something you probably never heard of called a slug. And seconds is an expression of time. The metric system, which is primarily Europe, force is expressed in newtons, length is expressed in meters, and mass is expressed in kilograms. And then something called the System International, which is the system that is supposed to be used across all scientific measurements. The length is meters, the force is newtons, the mass is kilograms, the volume is liters, time is seconds, and light is in candelas. Then we take and use, one of the nice things about the metric system is it's a base 10 system. As you know, in the foot-pound system, feet, there are 12 inches in a foot and 3 feet in a yard, which is kind of cumbersome. The metric system, everything is tens. And so you use prefixes. So a kilo is 1,000 or 10 to the third. So a kilogram is 1,000 grams. A centa is 10 to the minus 2 of whatever it is. So a centimeter is 1/100th of a meter, or it takes 100 centimeters to make a meter. A milli is a thousandth of whatever you're talking about. So a millimeter is 1,000th of a meter, and it takes 1,000 millimeters to make a meter, or 1,000 milliliters to make a liter. Micro is a millionth of whatever you're talking about. So a micrometer is 1/1,000,000th of a meter, and it takes 1,000,000 micrometers to make a meter. Nano is 10 to the ninth, or 1/1000,000th of a meter, or whatever you're talking about, and it takes 1,000,000,000 or 10 to the ninth nanometers to make a meter. You should memorize these 5 prefixes so that you know what each of these means. These are commonly used prefixes, and these should be memorized. Dimensional analysis is a way of converting one measurement to a different units of the same measurement. So if you wanted to say convert kilograms to grams, or millimeters to kilometers, or something like that, you can use something called dimensional analysis, which I will show you how we do that in just a second. So let's take an example in order to show you how this works. So we want to convert 3,124 inches to yards. Now we know that there are 12 inches in a foot, and we know that there are 3 feet in a yard. And so this foot cancels out that foot, and this inch cancels out this inch. And so when you do the math here, which essentially means you're going to divide this number by 36, you're going to have the answer in yards. So 3,124 inches equals 86.78 yards. And I have 4 significant figures here and 4 here. We have 434 kilometers into millimeters. So there are 434 kilometers, and a kilometer, 1 kilometer is 1,000 meters, and 1 meter is 1,000 millimeters. So we're going to essentially multiply this number by 1,000,000, or 1,000 times 1,000. Let's express that as a scientific digit. It would be 4.34 times 10 to the 8th. You'd have this number. Let's write this number down to show you how we got that. There's 3 zeros from here and 3 zeros from here. This cancels this. This cancels this. And so you start here, you write your decimal there, and it's going to be 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8. The next one is 22 yards in a meter, and I've given you a little help here. So you have 22 yards. Remember, 1 yard is 3 feet, and 1 foot is 12 inches. And I've shown you here that 1 inch is 2.54 centimeters. And we know that there are 100 centimeters in a meter. And all this stuff cancels out and you're left with meters over here. So if we take 22 times 3 times 12 times 2.54 divided by 100, we get 20. Try that again. 20 point. We started out with two significant digits here. So 20 meters. And I notice I put the decimal there to tell the person looking at this that that 0 is significant. So you start out with 22 yards and you get 20 meters. The last one, 452 kilograms. And I've told you that 1 pound is 454 grams. So we know that there are 1,000 grams in a kilogram. And there are 454 grams in a pound. And so 452 times 1,000 divided by 454. And so this is going to be approximately 996 to 3 significant digits. My calculator says 995.59, so I round up to 996. And you always have an answer, so this is pounds. When we come back, we will talk about measuring heat, that is, looking at temperature scales.